Hello, my dear aspiring pilots, students of CPL and ATPL. Here I'm with you with a series of lessons on air navigation. And I'm starting with the navigation numericals first. That means I presume you have a little bit of ground training. If not, with each lesson, keep reading the lesson and start doing the numericals. Numericals are a large percentage of the navigation examinations, and sometimes even 40 to 50%. Let me introduce myself. I'm Veteran Wing Commander S.K. Booty, and I'm now presenting air navigation numericals for CPL and ATPL students. And we will start with the altimeter. What is an altimeter? A pressure instrument which gives you the vertical distance above a particular datum. Datum point could be your ground, or it could be the mean sea level. Now, it has like a watch, hour, minutes, and seconds. It has got 10,000, 1,000 feet, and 100 feet needles. And between each 100 feet, there are then markings, 20 feet. Basically, it works on air pressure taken from outside the aircraft through this window called static vents. The pressure is brought inside the instrument case. What you see is only the front portion. This lies behind the instrument panel. It contains a flexible capsule which can expand or contract. The pressure in the capsule is set by the pilot by this adjustment knob and is shown to him on this window called subscale or Colesman window. This pressure may be in inches of mercury or hectopascals, earlier known as millibars. The reading of the altimeter is called main scale reading. And this 10,000 feet warning flag warns you when you are descending. When this flag starts appearing, it tells you that you are now below 10,000 feet and watch your speed. About 10,000 feet, this window is blank. Right. Now, how does an altimeter work? We set a certain pressure in the capsule called the window pressure or the datum pressure. If the datum pressure is here, let's say I've set this pressure at this particular aerodrome at this particular time, such a pressure in Q code, which you'll be learning, is known as Quebec Foxtrot Echo. If I'm on the ground, outside pressure is also same. My altimeter will read 0. As I start climbing, outside pressure keeps falling, capsule keeps expanding, and my reading keeps increasing. Okay. At the standard rate of, for every 1 HPA fall of pressure, my altimeter will register 30 feet increase in my altimeter reading. When my datum pressure is airport pressure, and I have reached at this particular altitude, there is a certain ambient pressure outside. QFE minus ambient pressure, this pressure difference, multiplied by 30 feet per HPA. If the difference is 100 HPA, it will read 3,000 feet. If both these are in inches, then the difference is multiplied by 1016 feet, not by you. It is done by the altimeter. And it gives you a reading called altimeter reading. So if your window pressure is QFE, this altimeter reading will be now known as your height. If at the time of takeoff, which we generally do in all flights away from our base called cross countries, I set the mean sea level pressure at this place. And how do I find out mean sea level pressure? That is called QNH. If QFE is at this aerodrome, let's say 990 millibars, and the aerodrome elevation is 450 feet, then the QNH will be more. How much more? QFE plus aerodrome elevation divided by 30. In this case, 450 divided by 30 will be 15, and my QNH becomes 1005 HPA. When I set that 1005 on the ground, my altimeter will show me so many feet above mean sea level, and the aerodrome altitude above mean sea level is called elevation. In the air, this pressure called QNH minus ambient pressure into 30 in HPA or 1016 if both are in inches. This is then called altitude. Altimeter is calibrated for a standard lapse rate of 1 HPA every 30 feet. For example, if your QFE is 990, as in this example, and the QNH is 1005 HPA. QNH is the mean sea level pressure at this place. Yeah, and I calculated that my QNH is 1005 hectopascals. Then what will happen when I reach this place, ambient pressure, if it is 790 outside, if I set the QFE, my altimeter will read 990 minus 790 into 30, 6,000 feet, and it will be called aircraft height. If I have set QNH, then it will read 1005 minus 790 into 30, 6450 feet, and that is called my altitude. Altimeter reading, a simple word use, indicated altitude, depends on the datum pressure. Same aircraft, if it sets QFE, his reading will be called height. If it sets QNH, it will be called altitude, which is above mean sea level, height is above ground level. And if it sets 1013.25 HPA, which is the standard or average mean sea level pressure on which the flight levels are flown, then the reading is called QNE, or it is called pressure altitude. The flight levels allotted to the aeroplanes are pressure altitudes in multiples of 500 feet. Different flight levels are allotted to different aeroplanes, and when you are flying and over any particular place, if an aircraft is crossing you from the reciprocal side, or it is crossing you from left or right, don't worry, there will always be a difference in the flight level and you are safe. You are safe. Of course, don't forget to maintain proper flight levels. The slight errors in the flight levels have been catered for in giving you this 500 feet minimum spacing. At higher altitudes, it increases, spacing increases. That we will study in air regulations. How are the flight levels allotted? But flight levels are nothing else but pressure altitudes. And pressure altitude is when altimeter datum is set to 1013.25 and flight levels are in multiples of 500 feet. And a flight level 240 means you have to fly at 24,000 feet on 1013.25. The standard procedure is that over an aerodrome, unless the next point where you are going is straight ahead or within 15 degrees, aircraft will be asked to turn left or right and report overhead at an altitude which is called set heading altitude. And you take off on Quebec November Hotel, QNH. This is called set course or set heading altitude. That means now I'm going to set my heading or direction towards the place where I want to go. That's my first checkpoint on the route. And I also start climbing at a rate which will be from your flight manual, and in this aircraft is climbing at 1,000 feet per minute. Now, sometimes they do ask you how much have you actually climbed and how much time it will take you to climb and how much distance you will cover during climb, right? In this question, he says, set heading at 4,000 feet above the aerodrome, climb to flight level 240 at 1,000 feet per minute. And now I find out if I'm climbing to 24,000 feet from 4,000 feet, that means here that this distance should be 20,000 feet. And practically, yes, but theoretically, they say, no, give me the exact vertical distance. How much have I climbed? Okay, now 24,000 minus this set heading. And since this is a pressure altitude, I find the pressure altitude here. Now I've set 1013, 03.25 QNH. If I set 1013.25, what will my altimeter read is known as pressure altitude. And remember, whenever I increase the data pressure setting, the altimeter reading will also increase. So now, since I'm increasing it by 10 millibars, altimeter reading will increase by 10 into 3,300 feet, and it will start reading 4,300 feet. So now, what actually I've climbed is 24,000 minus 4,300, 19,700 feet. Okay, that has been my actual climb from this set heading point. And 19,700 divided by 1,000 feet per minute rate of climb, my time will be 19.7 minutes. How much horizontal distance will I cover during this time? Time into speed is the distance. So this time into ground speed, which I will calculate in my flight planning per minute, divided by 60 per minute, since this is minutes, will give me the distance I will cover in nautical mile. When I reach this point, which is called top of climb, where I'm going to level out. So this point in the air and on the ground is called top of climb, and this is my climb distance. And this is my vertical distance, 19,700 feet from set course, and 20, add another 4,000 feet. It will give you the distance you have climbed from the ground. Okay, so that is your vertical distance and horizontal distance that you have climbed. With this in mind, you'll be able to solve these questions on altimeter. And also remember, during climb, let's do a little bit of theory also. At a certain altitude given in your aeronautical publications called transition altitude, TA, the aircraft was so far flying on QNH, will now change over to 1013.25 and maintain 1013.25 there onwards till you reach the next place. At next place, when you are descending, will at transition level change over to the local QNH here. So when you land over here on local QNH, your altimeter will read the aerodrome elevation of this aerodrome that you have so many feet above mean sea level. Remember, below transition altitude remain on QNH, above transition level remain on 1013.25, and all flight levels are above the transition level, and this layer in between is called transition layer. How these are calculated, we will study in MET. Fine. Introductory lesson, how an altimeter works and the altimeter setting procedure. Bye-bye for the time being. Remain with me. There are many more lessons coming up for your numericals. And if you like my lesson, don't forget to press the like and also subscribe to my channel and remain with me. And I shall try my best to give you a much better standard than you have at the moment. Good luck. All the best. Happy landings.